A very good evening, students. So today we are going to do the problem of traveling salesman, which is an important class of assignment problem, and it do have an importance from examination viewpoint. So what is different in this kind of assignment problem is, in earlier problems, what we have on one side we had have resources, and on the other side we had have activities, and we were assigning those resources to those activity. We were assigning those resources to that activity. But now in this case, the problem of traveling salesman, what we have to do, or what we have a salesman which has to complete his trip or tour for different cities without leaving anyone, and he has to minimize his cost, or maximize his sales. Usually in case of traveling salesman, the matrix given is of cost matrix, means the traveling cost of that particular salesman has been given from different cities to different cities. So the condition attached with traveling salesman is that if salesman starts his journey from city A, then he will end his journey on city A. It means that he will have to start the journey from the same city and he will have to end at the same city. Okay. And another condition, during the completion of his journey, he will have to cover other cities as well. If he is returning his home city means from where he has started his journey, without visiting any city, then the assignment problem will not reach up to its optimum solution, because he again will have to start his journey from his home city to complete the journey. Is it okay? Or it will not be possible to get optimum solution. So let's start and understand it with an example. Here are the different cities, and suppose you are residing here at Patiala and you have different relatives residing in these cities: Rampura, Ambala, Rajpura, Sarhand, Khanna, Ludhiana, Amlo. So if you start your journey and you firstly visit Rampura, and then if you try to visit Ludhiana, and then try to visit Sarhand, then try to visit Ambala, then try to visit Khanna, then try to visit Rajpura, then again want to return to Patiala. In that case, you can see that your cost will maximize. So if you are going to have a round trip, means that from Rampura, Ambala, Rajpura, Sarhand, Khanna, Ludhiana, Amlo, Patiala, in that case maybe your cost will be minimized. As in this problem we have a round city problem, it doesn't mean that each and every single traveling salesman problem will have a route in round shape. Thus, what you have to do, you have to find out which city should I visit first, and the city we have visited, from that city which city next, and accordingly we are going to see what the cost is, and that cost has been measured here, and we are going to make an assignment to them, and we are going to take those conditions in mind, and we will try to sort it out. The way to solve this problem is similar as we were doing in our earlier problems of minimization, maximization. Usually this kind of problem is of a cost matrix, so that is a problem of minimization. So we are just going to do row reduction, column reduction, making assignment, and thereafter if required then improvement, and so on. Then improvements, and again assignment. If improvement has not worked, then assignment. If assignment hadn't worked, then for improvement, and so on. Okay, so let's start. We will try to solve this question. So here it is. What will be our first step? That is row reduction. Row reduction. So if we are going to do row reduction, in our first row smallest element is 2. And one more thing I had forgotten to tell you, these hyphens or dashes, these are indicating that A cannot visit A, B cannot visit B, C cannot visit C, D cannot visit D, E cannot visit E. Means no assignment can be done here. No assignment can be done here because A cannot visit A, B cannot visit B, C cannot visit C. So these are the hyphen points, or these are the points where no assignment can be done. So in a way it is also a kind of restricted problem. Okay, so let's start. So in each and every steps these values will remain same. These values will remain same. So let's start. Row reduction. A, B, C, D, E. A, B, C, D, E. So 2, these value will remain same. This value 3 minus 2 1, 6 minus 2 4, 2 minus 2 0, 3 minus 2 1. Again the smallest element is 2, 3 minus 2 1, hyphen 5 minus 2 3, 2 minus 2 0, 3 minus 2 1. Okay, next smallest element is 4, 6 minus 4 2, 5 minus 4 1, hyphen will be hyphen same, 6 minus 4 2, 4 minus 4 0. Next one is smallest element is 2, 2 minus 2 0, 2 minus 2 0, 6 minus 2 4, hyphen will remain same, no assignment can be done here, 6 minus 2 4. And the smallest element in this row is 3, 3 minus 3 0, 3 minus 3 0, 4 minus 3 1, 6 minus 3 3, hyphen will remain same. So now we will move towards the column reduction. Again A, B, C, D, E. A, B, C, D, E. Now column reduction, smallest element is 0, smallest element is 0, so the values will remain same, hyphen 1 2 0 0. Again second column value will remain same, 1 hyphen 1 0 0. Third column we have a smallest element 1, so 4 minus 1 3, 3 minus 1 2, hyphen 3 0. Fourth column's value will remain 0 0 2, hyphen 3, and fifth column will remain same, 1 1 0 4, hyphen. Now what next we do? So So for the time I am just putting the line to differentiate my table, as I had made it a little bit congestive. So let's do the assignment. And you guys know the rule of assignment. We are going to look for single zero in first row, then first column, then second row, then second column, and I'm repeating the same thing again and again in my every video. So I think now you guys are fond of that thing. So let's have a look for single zero in the first row. Is there any single zero? Yes. So we are going to make an assignment to it, and we will cross every single zero present corresponding to it. Done. We are going to make an assignment row wise, and now column wise. Is there any single zero in first column? No. Is there any single zero in second row? No. Is there any single zero in second column? No. Is there any single zero in third row? Yes. So we are going to make an assignment to this. As the assignment has been row wise, then we are going to cross every single zero present in the or corresponding to that assignment. Done. Third. Is there any single zero in third column? Sorry. Yes. So we are going to make an assignment to this, and we will cross every single zero or every zero present in the row corresponding to that assignment. Done. Third column has been done. Now, is there any single zero in fourth row? No. Is there any single zero in fourth column? Yes, but those has been assigned or crossed. Is there any single zero in fourth column? Sorry, fourth row, fourth column, fifth row? No. Fifth column? No. Again we will start from first row. Is there any single zero in first row? No. Is there any single zero in first column? Yes. So we are going to make an assignment to this. And what we have to do? We have to cross the zeros corresponding to that. Now, in this matrix, what we have done? We have assigned zeros, or we have crossed zeros. So no zero has been left without assignment or crossing. So let's check whether we have arrived at our solution or not. So let's check. Number of assignments are 1, 2, 3, 4, and number of rows and column are 1, 2, 3, 4, 5. So we hadn't reached our solution, so we have to make an improvement. So let's make the improvement, and for making the improvement, what is the funda? So let's start. Mark the row which have no assignment. We have marked the row which have no assignment. Now let's have a look on the crossed zero in that marked row. Is there any crossed zero? Yes. So mark that column. We have marked that column. Now what to do? As rows has been done, and now look at the column. Is there any assignment? Yes. So mark that row again. We have marked that row. Now again look in the row which has been newly marked. Is there any zero crossed? No. It means that further marking cannot be done. So let's cover the elements with lines, or the steps of drawing the lines, minimum lines, to cover the zeros. So cover the lines, cover the rows which are unmarked. So here it is, and cover the column which has been marked. Now what is the next step? We are going to find out the smallest element from the uncovered element, and we are going to reduce it from the uncovered element and going to add into the elements at intersection point. These are the points, and remember, at this intersection we are going to add nothing because no assignment can be done here. Okay, so let's we are going to frame another table, improved table. So again, here it is: A, B, C, D, E. A, B, C, D, E. It will remain same, and the smallest element is 1. So 1 minus 1, 0, 3 minus 1, 2, 0 will remain 0, 1 minus 1, 0, 1 minus 1, 0, hyphen will remain hyphen, 2 minus 1 1, 0 will remain 0, 1, 1 minus 1 0, 2 will remain 2, 1 hyphen 2 plus 1 3, 0, again 0 0, 3 hyphen 4. At this hyphen we hadn't added anything. Reason because we cannot make an assignment here. 0 0 0, 3 plus 1 4 and hyphen. That is our improved matrix. And now what we have to do, again the same thing, we are going to make an assignment. So let's see, is there any single zero? No. Is there any single zero? No. Is there any single zero in the first column? No. Is there any single zero in the second row? No. Is there any single zero in the second column? No. Is there any single zero in third row? Yes, here it is. So we are going to make an assignment to this, and we will cross every single zero corresponding to that assignment. We had made an assignment in the third row. Now we will look at the third column. Is there any single zero in third column? Yes. We will make an assignment and cross every zero corresponding to that assignment in the row. Done. Third column. Is there any single zero in the fourth row? No. Is there any single zero in the fourth column? No. Is there any single zero in the fifth row? No. Is there any single zero in the fifth column? No. Now again the process will be the same. Is there any single zero in the first row? No. First column? No. Second row? No. Second column? No. Third row? No. Third column? No. Fourth row? No. Fourth column? No. Means we cannot find any single zeros. Now what we have to do next we are going to look at the rows or column which have double zeros. Again the process will be the same. We are going to look at the first row first, thereafter on the first column, thereafter on the second row, thereafter on the second column, thereafter on the third row, thereafter in the third column. So let's start. Now because we are not finding single zero, we will look at the double zero. Just for once we have made an assignment, again our funda will be the same. We are going to look for the single zero. So we are going to make an assignment to this. The reason we can make an assignment to this also, the reason behind making this assignment is, normally what we do, we are going to take first zero. If we are making assignment in a row, then first from the left. If we are making assignment in the column, then first from the top. Okay, so we have find double zero in our first row, so we are going to make an assignment to this one because it is the first one. And when we are going to make an assignment to this, we are going to cross every zeros corresponding to it in the row and column. Here done, here done. Is it done? Again after making assignment in this way, we are again going to look at the single zero. Once we have looked for double zero and we had made an assignment, again we will go for single zero. If we wouldn't find it, then we will go for double zero. So is there any single zero in the first row? No, because when we cannot make an assignment. In first column? No. In second row? No. In second column? No. In third row? No. In third column? No. In fourth row? Yes, here it is. If in the fourth row we have made an assignment, so we are going to cross this, and ultimately it will be the last zero and we can make an assignment. Reason being because we are not in need. Further we can do, we have made an assignment in the fourth row. Now is there any single zero in the fourth column? Yes, so we are going to make an assignment. So let's see that whether we have arrived at our solution or not. We have arrived at our solution or not. So number of assignments 1 2 3 4 5. Yeah, okay, number of assignments are equal to number of column or row. So as per the rule of assignment, wherever number of assignments are equal to number of rows or column, we are at our optimum solution. But in this case, the problem of traveling salesman, may be or may not be we are at our optimal solution. Usually we are not at our optimal solution. Now let's check it. Okay, so let's start from any city. Wherever city you will start, you will have to return at that city. So let's start from A. Usually we have started our journey from A. We have visited A to B. Okay, now we have reached B. From B we have moved to D. Now we have to come to D, and from D we have moved to A. What mistake we have done, or what that traveling salesman has done? He has missed the city C and E. C and E has been missed. It means that this is not our optimum solution. It means that this is not our optimum solution. We have to further improve that matrix, or we have to improve our assignment. Okay, and how we are going to improve that matrix or that assignment? We have to frame again another matrix. The same matrix will be copied and pasted here, or you can say same matrix will be copied here, and we will try to make assignment in any other way, so that our assignment problem can be solved according to the condition of traveling salesman. So we are going to make another table. This table will be the same. Let me copy it. For your time convenience, I have copied it, and you can see that is the same matrix but without any assignment or crossing. So if we are not getting our matrix as per our condition, we are going to make an assignment in an innovative way. And what is that innovative way? That in that matrix our first assignment will be to the value minimum next to 0. Minimum value next to 0. Now what is the next value to 0? That is 1. That is 1. So find out, is there any one? Yes, here at two places. So let's see that which one we can make an assignment. We can make anyone, and it is dependent on you that if you will choose right one, then your answer will came in first table. If you will choose wrong one, then again you will have to choose another one. Okay, so for the time being, we are going to choose usually the first row, first column, second row, second column. The first one I had have seen, here it is. So I am going to make an assignment to this, and once I have made an assignment to this, I am going to cross every single 0 corresponding to it in this way. So wise here, done. So again the funda will be same. First row, first column, second row, second column, third row, third column. Okay, so let's start. First row, no. First column, no. Second row cannot be assigned. Second column, yeah. Third row, yes, there is single 0, yes. And we are going to cross every 0 corresponding to that assignment. Third row, third column, fourth row, fourth column, yes. Is there any single 0? Yes. We can make an assignment, and we are going to cross every single 0 corresponding to it. Fourth column has been done. Fifth row, fifth column, done. Now you can see that first row, first column, second row, second column, third row, third column, fourth row, fourth column. We have a double zeros in each and every single 0. And what I have said you earlier here, first from the left or first from the top. But whenever we are making an assignment problem in case of traveling salesman, you will have to use a common sense a little bit. How? Check it. A to D, and if you're going to make an assignment to the first of D, first 0 of D, then your assignment condition is not going to fulfill one. Not going to fulfill. So we are going to make an assignment to this one. We had made assignment to this one, so we will cross this and this. Last 0 we are going to make an assignment to this. Let's check whether our assignment has been solved or not. A to D, D to B, B to C, C to E, E to A. Yes, here it is. A to D, D to B, B to C, C to E, E to A. So here you can see that he has started from A and ended his journey at A. That is our solution. And how to write the cost? A to D, A to D. We are going to take it from the original matrix, A to D. 2 plus D to B, D to B. 2 plus B to C, B to C. 5 plus C to E, 4 plus E to A, 3. 4, 3, 7, 5, 12. 12 and 4, 16. No, 16. That is our minimum cost, and that is our optimal assignment. Okay, so that wasn't our optimal assignment, whether it was satisfying the condition of number of assignments equal to number of columns. But in case of traveling salesman, we had have an additional condition that his starting and ending cities should be the same, and it should cover each and every city given in the matrix. If our solution is leaving any city and returning, our salesman is returning to his hometown without reaching or without visiting any city, then our solution is of waste. It will not be our optimal solution. So we have to what the innovative things we have done. We had made an assignment next minimum. Suppose there was no 1, then we were going to make an assignment to 2. Next minimum to the 0. Okay, next smallest element to the 0. And second thing is, in the end, when we are making an assignment, we have to use a little bit common sense, or we have to see that A to D, B to C is their circle. If we were going to assign this, then again our circle wasn't going to you can say get completed. So we have to use a little bit common sense, or you can say hit and run way. Okay, so that is the traveling salesman problem. I think you guys have genuinely attended this lecture, because this problem have very important role in our examination. Usually in a second or third attempt we have seen this kind of problem in our examination. Okay, so have a good day. Tata, bye bye.